It's Friday night. It's Pop Astro Live. And we are coming live from Anglesey. Good evening, popular astronomers. So we're just going to give people a couple of minutes to join the stream. So I'm just going to play the little countdown video. And away we go for the evening. Whew. Okay, here we go. Hey, good evening, popular astronomers. It is Vicky here, coming live from Anglesey with a mug full of musty water. Now, you might remember from previous episodes of Pop Astro Live that when I've got musty water, it means that I am down in the stable stroke laundry where I get decent internet. Last week, my internet was a bit fuzzy, so I've come back down to the stables this evening. And wow, look how many clothes I am wearing. This building has got glass walls, right? And I was dreading coming down here because it's completely abandoned and disused at the minute. It's not derelict, it's a luxury holiday accommodation, but there's just been nobody down here. And all I could think about doing was bringing the heater down, getting it switched on in the room and getting it warmed up. And that is one of the things that's been putting me off coming down here for the past couple of weeks. And guess what? The heater's broke. It's been in the boot of my car for a couple of weeks and not been used, and it must have fried it. So if you see me gradually encasing myself in extra layers throughout the show, in fact, I pretty much need to get the coat back on now, just to show you that I am wearing colourful clothing. So anyway, good evening. This is Pop Astro. 16 comments already. Wow, 17 comments. Let's have a look. What's happening on the wires? Hi, Paul Sutherland. How are you? Mr. Butterfly Man. Hello, Sonia G. Hi. Catherine. Hello. Greetings from Kathy and the Ragdoll Cats. That sounds like an ace band. It's Kathy and the Ragdoll Cats. Good evening, Vicky. I'm always well. Thank you very much. Oh, everybody, David Graham, thank you. It's the only job in the world where you can legitimately interrupt yourself with Facebook comments all day. Wow, look at all these lovely comments. Too many to even display. Did you decide to put a name on my Black Panther? I didn't actually. Not much stargazing this week due to cloud, but could just see Sirius through a gap in the clouds earlier this evening. David is one step ahead of everybody because what I want you to do is start commenting about what you have seen in the sky over this past couple of weeks. This morning, when I woke up at about 7:45, I opened the window and no, I didn't open the window at all. That would be a stupid thing to do at this time of year. I opened the curtain and there was the full moon setting bright pink into the horizon. That was absolutely beautiful. And I got in the sea for a full moon swim, very high tide, big waves. Now but a swimming costume, I'm pleased to announce. Consequently, I feel fantastic because of all the mental health benefits of chucking yourself in the sea. So that's what I've done today. That was my celestial experience. Hello, everybody. Has anybody seen Uranus yet? Smirk the moon. Yes, it was good, wasn't it, Sonia, the moon today? So thank you, everybody, for all of those comments. It's wonderful to have you all along. So this is the Society for Popular Astronomy, and we rely on members to keep us going and to give us motivation and reason to live. One of the best ways that we can reach new members is for you to hit the share button on this video. Don't just do it once, do it 10 times throughout the feed. As long as Facebook doesn't flag us up for spam a lot. I think it should be okay though. Hit share on this video, and every time you share it, an asteroid changes its trajectory and doesn't hit the planet Earth. So it's vital that you share it. So this evening we have got What Has Cosmo Been Looking At? This is the new game. We have got two special guests for you and news and space weather and space traffic and travel from Eleni. Excellent. So on this evening's show, we have got Ian Morison, and he's going to be talking about observing and imaging the sun in solar cycle 25. Ian joined Jodrell Bank Observatory, my favourite place in the whole wide universe, before becoming a staff member. He joined as a student in 1965 before becoming staff in 1970. He initially worked on data acquisition systems for the observatory's own instruments, including the Lovell and Mark II radio telescopes. He then went on to play a key role in the development of Merlin, an array of radio telescopes with a resolution in the radio spectrum comparable to that of the Hubble Space Telescope in the optical. Thank you, Wikipedia, for that lovely, succinct description. In 2007, Ian was appointed as the 35th Gresham Professor of Astronomy, a position previously held by, Cosmo knows, Christopher Wren. So we have also got Jonathan McDowell. He's been on BBC News recently talking about the new launches by SpaceX. Jonathan is a great space expert, now living and working in the States. Maybe him and Ian know each other from days gone by at Jodrell, actually. He works on Chandra X-ray telescope at the Harvard-Smithsonian Center for Astrophysics. So tonight we peer through the universe with multi-million-dollar X-ray spectacles and expect some beautiful imagery. So first of all, let's say what you've all been looking at. Hi from a brand new member. Hello, Michael Saltzman. What a pleasure to have you as a member on the SPA. I can't wait to see Ian. Fangirl Calf there. Looking forward to seeing Ian. Tried to image the ISS transiting Mars. Clear an hour beforehand, but by the time the transiting Mars, what a catch that would be. The transit was due. That part of the sky was clouded over. Boo! Simon Bakewell managed to see it in the same field of view as Mars. That's pretty cool. Bit of astronomy. What would the ISS look like transiting Mars? Do you like go across the disk? That would be fantastic. What a catch. So first of all, we've got a new guessing game for you. Cosmo the Sloth. He says he's better than Sooty. He's going to read out. No, he's not at all going to read out. He's going to tell me a list of clues, and I want you to guess where Cosmo has been in the solar system this week. So what's that first one, Cosmo? It's the brightest object answer in the comments. It's the third brightest object in the night sky after the moon and Venus. And in the meanwhile, I'll read Sonia's comment. Just like to say thank you to everyone for the warm welcome on the Pop Astro Forum. New friend Sonia. There we go. So first one to comment. It's the third brightest object in the night sky after the moon and Venus. What's that second clue? What's the second clue, Cosmo? It's the most expensive object ever built. What could it be? So it's the third brightest object in the night sky after the moon and Venus. It's the most expensive object. Sorry, I forgot to say Cosmo is a telescope sloth. He lives on my telescope, which is why he's been looking through it. That's the synergy we're looking for. Oh, serious? Is that what you've seen, or is it the most expensive object ever built, Simon? What do you reckon? And the third clue, I can't read that out, Cosmo. That's rude. Astronauts drink their own wee-wee inside it. You can't say that. It's the ISS, everybody. Well done. And the first person to get it correct was Kath. Well done, Kath. But because you are an employee of the SPA, you don't win the £1 million prize. I'm so sorry. It's gone to Catherine Grimes instead. Well done. It's winging its way via a large novelty check all the way to you, carried by the ISS, no less. Excellent. Okay, so this week the ISS is making a spectacular series of passes over the UK, continuing until the first week in Feb. You can view it from your back garden as long as you have a good view of the sky, so no need to travel anywhere to see it. There is no mistaking the ISS when it glides silently through our skies. It is often brighter than any celestial object at night other than the moon and moves as swiftly as a nearby aircraft, but without any noise or accompanying flashing lights. Yet it's at least 400 kilometers above your head. And there you go. ISS facts, cut and pasted, no less, from the Pop Astro website. I think Robin wrote that article. Thank you so much. Okay, we are now going to our first guest. It's Ian Morison. Here you come, Ian. He's looking very smart.
Not really. Can you hear me?
Yeah, we can hear you, Ian. How are you?
I'm fine, thank you very much. And just hoping we get some more clear skies.
Oh,
we haven't had very many, but when we have, all my friends, we all get out there and have a go and try and take some pictures and have a look.
So, Ian, whereabouts are you this evening?
I'm in my home in Macclesfield in Cheshire.
Very close to the beautiful Jodrell Bank there.
Well, we're about 8 miles away. I'm still on the staff there. They just forget to pay me anymore. That's all.
Oh, right. Okay. We need to have a word with someone on the payroll then.
No, it's all right. I do a night sky page for them every month, amongst other things. So.
Very good. Oh, Kath says, I think your fan, Kath, is saying that you're looking very dapper.
Well, I thought I'd make an attempt anyway. I could have worn my SPA top, but I thought this was slightly smarter.
They sent me the wrong size, so I'm not wearing it tonight. And so, Ian, what is your background? Just give us a little rundown of your background, please. Very impressive.
Oh, really? Well, I was lucky enough to live about 100 yards from the south coast, so it was very dark, and I had to wear quite thick glasses when I was about 11. My father was a great friend of our little local optician in our little village, actually, surprising. He gave me lenses, so I made little telescopes with them. I could certainly see the craters on the moon, and I think I saw the moons of Jupiter. I can't claim I did any more than that, but I enjoyed astronomy. If I ever got a prize at school, I got the odd physics one occasionally. It was always an astronomy book, like Every Man's Astronomy. And I was lucky enough to get into Oxford and do an astronomy course there, actually, not for very long, but it was good. I had no idea what I was going to do at the end. I'd actually been in the Royal Signals, the officer training course. I like radios, I liked astronomy, and just as I was revising for my finals, I saw an advert saying, "Come and read radio astronomy at Jodrell Bank." I thought that fitted quite well, and I've been there ever since.
Oh, Ian. Okay, well, what a fantastic history. Now we have everybody knows that this show can, like, sometimes it flummoxes me. It's all brand new software. It's completely new on the market. All of this software is, and sometimes it doesn't like to screen share. So we've had a last minute panic with your amazing. What's your slideshow on tonight, Ian?
Well, it's about observing and imaging the sun in solar cycle 25.
Okay, so what we're going to try and do now is some live IT as it happens, because you've emailed me your PowerPoint and we can't get it to go full screen. So I'm going to ask any amazing person there. I think I've got the latest version of PowerPoint. If anyone wants to tell me what button to press on this, please, so I can get it full screen, I'd be most grateful. But if not, we'll just continue like this, Ian. But should we let's just see. View. You said it was under view. Is that bigger?
Well, no. Slide. Click on slideshow, which is just to the left. Click on slideshow. Up one and to the left.
Up one and to the left.
Yes, review is above your thing. Now go one to the left. It says slideshow. No, to the left. That's it. Click on that.
That one, yeah.
No. Review. One to the left. That's it.
Oh, we did it.
Yes.
Wow. Okay, Ian. Now I can't see you now, so I'm just gonna. Oh, I've done it wrong. I've taken it out. Let's have a look. What was it? I pressed play from current slide. There you go.
Yes. Good. Okay.
Right. Okay, Ian. I'm just gonna let you talk, and I'm gonna be your IT operator.
That's very good. Okay. Well, let's begin. And it's very nice to be on the program. I've been associated with the SPA for many, many years. I was your president, about 20 odd years ago, actually, around the turn of the millennium. And I'm still your imaging and instrument advisor. So this is combining both. Anyway, solar cycle 25. What is a solar cycle? Next slide. Well, let's try and explain. Imagine that the sun has a well-ordered magnetic field, and the field lines pass through the surface material, which means actually that the solar field is trapped a bit in the surface. And this is the problem. The equator of the sun goes round once every 26 days, but nearer the poles, that increases to about 36 days. And that has an interesting effect. Next slide. So, picture on the left. Let's imagine it starts exactly like that. A magnetic field line comes out of the North Pole, goes straight down and down into the south. But if you think about it, as the sun rotates, the equator moves around further than the poles. So after one rotation or two, can you see that line looks a bit curved, the second picture? And every time the sun rotates, every sort of 28 days, whatever it is, it becomes more and more curved. So eventually you get something that looks a bit like the picture on the right-hand side. Does that make sort of sense, anybody? Just say, oh, she's saying yes. Okay.
Yes.
Now, the best thing I ever made when I was a teenager was called a Keelcraft Ace. It was a rubber-powered aircraft with a wingspan of about 5 feet, 4 or 5 feet. As you wound up the rubber, some of you may have done this in the past, it starts up winding up very uniformly. It just goes round, round, round. But then there comes a point when it starts bubbling out sideways. And that's exactly what happens to the solar magnetic field when it gets twisted up too much. Next slide. So that's what I've just said. So we can actually go to the next slide. I think I'll show you the pictures. This is what happens as the sun's field comes out and then it goes around and goes in again. At those 2 points, the magnetic field prevents the heat coming up by convection from inside. So those parts of the sun's surface are cooler by about 1,000 degrees. They're still actually pretty bright, but relative to the rest of the sun, they look dark. So we call those sunspots. So that's why we get them. Next slide. And there you can actually see a couple more little pictures of it. And on the lower right there, you can actually see a picture in what's called hydrogen alpha. It actually shows you the magnetic field lines as material actually is sort of spun along them. A lovely, lovely photograph. Interesting, actually, that the lines go from south to north, in this case in the north, and from north to south. They swap over in the 2 hemispheres. So next slide. Now that's a lovely picture of the sun during what's called solar maxima. And you can sort of see some of the effects of the magnetic fields. It's a bit like iron filings. And over on the right there, you can see those lovely loops where material has gone up, the field's gone up and come back down in again. Next slide. So this is what happens. As it becomes wound and wound and wound up, you come to what's called solar maxima. At that point, we get the maximum number of sunspots we see on the surface. Those sunspots then break up and you go down towards what's called solar minima. The period between the solar maximums or minima is about 11 years, and that's called the sunspot cycle. Next slide. Ooh. And there's a lovely picture showing you the sunspot numbers over a very long period of time and the sort of pictures we have of the sun from solar minima, that's that picture lower on the left, to maxima, top left and bottom right. Notice that there were very few sunspots seen in the latter part of the 1600s. That's called the Maunder minimum. But as you can see, we've had some quite big sunspot activity, certainly in the middle and last part of the last century. Things have wound down a bit now. Next slide. So this is what we've had in cycles 23. 24 was a lot lower in terms of activity, 23. And this is what we predict now, or what is predicted, because it's not by me, for solar cycle 25. And it's predicted to peak around July 2025. And you can see it was down to its minima in around 2019, 2020. Next slide. So there's just a comparison of what the sun can look like in rather special wavelengths in maxima and minima. It really makes quite a difference. Next slide. This is a picture I took in December 2019, and I emailed that to my friend saying, is this the most boring picture of the sun you've ever seen? Because there's absolutely nothing to be seen at all. And we had quite a long solar minima, and we really didn't see anything very much for well over a year. Happily, things have slightly started to wake up. Next slide. So how can we look at the sun? Well, first of all, you must be very careful. And we use very special filters to vastly reduce the sun's brightness. And let's show you 2 of them, the next slide. On the left is a filter made of what's called Barder film. It actually gives you a rather blue-white image of the sun. On the right is a much darker one, which gives you a picture which is much more like the real color of the sun. Now notice they've got some little screws to actually make sure it's attached on the front of the telescope. Having said that, it would be disastrous if they ever fell off. So I'll always use black tape to actually make sure that they're totally secured on the front of the telescope. Most of my astronomy is done either using black tape or blue tack. And the next slide. And there's a picture of the sun. During the last solar, sort of just after Maxima, you can see some of the nice sunspots across the northern hemisphere of the sun. A pretty one. And the next slide. And that's a close-up of some of those sunspots. These are taken with a system I shall tell you about in just a few minutes. You can see a little bit of sort of structure in the surface, can't you? Those are called solar granulations. What happens is that the heat from the sun is brought up by convection, and that little bit of hot material cools down, and the outer parts, it then sort of goes down again around the hot bit. So we get these little patterns on the surface. And you can see we have the umbra and the penumbra of the sunspots. Sometimes you actually see a white region around the penumbra, that's the outer part, which is called the plage. And our plage beach, think of the lovely white beaches in France. And the reason is that the heat that can't get out, because the magnetic field's stopping it coming out of where the sunspots are, works its way around the edge and comes up at the outside. So those bits are slightly hotter. And the next slide. And that's just a few pictures that I took. Again, this was sometime during the last solar cycle, but you can see that we have some nice sunspots. You can see them in the whole image. You can see some at the bottom there, some at the top, and I've used something called a Barlow lens to increase the magnification to show them in a little bit more detail on the lower left and the top right. And the next slide. Okay, now this is perhaps the most expensive, but the best way to view the sun in, they say white light, some people say continuum, and a number of manufacturers make what is called a Herschel Wedge. That's actually designed by John Herschel, the one that actually went down to the southern hemisphere and made lots of lovely discoveries there. It has to basically have a prism that reflects quite a bit of the light up towards the camera. A lot of it goes to the back, and you can see it on that back screen. So it actually acts as a solar finder. And what they do is they put in a filter, in this particular Barda one, called a solar continuum filter, which is lime green. So the view you get of the sun is actually green, which of course it obviously isn't. But that, it is said, gives you some of the sharpest and the best views of the sun you can see in continuum emission, so-called white light. Next slide. And that's just a cutaway showing you, I'm not sure you can see the bottom half. I've got something over the top, but you get the basic idea. The light comes in from the right-hand side. A percentage is brought up, is reflected up to the eyepiece. There are then a number of neutral density filters to cut down the brightness, and then this solar continuum filter. At the back, there's a bit of a heat sink and the ceramic plate, so you can actually see when you're pointing towards the sun. And there's several manufacturers. Now, I think this is the most expensive one, about £400, but it's certainly the best. Next slide. That's actually a picture I took with it as a sunspot group at the end of the last solar cycle was going towards the limb. And quite honestly, you cannot do better than that if you're imaging in white light. It is a lovely system to use. Next slide. Well, a lovely thing we saw in 2016 was the transit of Mercury. Now, in fact, I'd actually come back from the south of England. I arrived actually at, I think it was Plymouth, on a cruise, on a ferry from France, and it was cloudy. I knew it was the day of the transit. I rang my wife up in Macclesfield. She said, it's clear in Macclesfield. So I had to say I drove back from Plymouth to from Portsmouth to Macclesfield rather quicker than I should have done. But I was just in time to capture Mercury on the face of the sun. Can you see a little black dot over to the left? That's not a sunspot, that's Mercury.
Wow.
So next slide. Now, another way that we can observe the sun and also image it is in the light of what's called H-alpha emission. This is a lovely deep red color. It's emitted by hydrogen when it's excited, perhaps by ultraviolet light. It's the red color we see in these lovely emission nebula, all like the Lagoon Nebula, the California Nebula, the North American Nebula, and so on. But you have to have a special so-called H-alpha telescope, and sadly they're not very cheap. Next slide. Now what actually happens, you've got to isolate this very narrow band where the H-alpha emission lies. And the first thing that is used is called an etalon. It's two very closely spaced plates of glass, and essentially it produces a comb of narrow band pass bands right across the visual part of the spectrum. They're about 10 angstroms apart. There is a slight problem that the effective separation, which controls the actual wavelength, is determined by the atmospheric pressure in between the two bits of glass. And of course that changes either because the pressure goes up and down or because you go up a mountain or something. So you have to correct for that. Next slide. And we have to so-called tune the etalon. There are three ways of doing it. One thing to do is to tilt the etalon slightly. So if you have a road, you go straight across, that's the minimum distance. If you go across at a slight angle, that increases the separation, and that's how you can tune it that way. Or you can actually push the plates together. You have a little pad on the plates and actually squash them together a bit. And the final one is actually to control the air pressure between the plates. And that enables you to actually tune the etalon as well. So those are the three ways. Next slide. So you have these little narrow bands, 10 angstroms apart. So that's at the front really, or the middle of your H-alpha telescope. At the very back, there's a thing called a blocking filter that's like a normal H-alpha filter we might use for imaging in the H-alpha band, and that basically selects the one you want. So all that comes out is that very narrow band within that red band, overall band I've shown you there. So next slide. And the cheapest, and actually still very good, solar telescope is called the Coronado PST. They're built by Meade, and a colleague of mine's got one, and he produces some wonderful images in H-alpha, as this one here. And you can see sunspots, you can see these lovely white regions as well. The dark regions over the top are called faculae, and you can see over on the left there, just below the picture of the PST, there's actually a prominence. So there's some lovely things we can see in H-alpha. Of course, the pictures we get are monochrome, and sometimes we actually color them either red or perhaps orange. That's a very good buy. The next slide. A lot of people have got the Coronado 60mm ones, and they are very, very common, and they're actually they're pressure tuned. Little knob you can see there halfway down, you just move that, it adjusts the spacing between the etalon plates, and it tunes it very, very easily. So the next slide. This is the Lunt telescope, also 60mm, is the one that I've got. This one is pressure tuned. That little big round thing coming out on the left is a cylinder, and you sort of screw it in or screw it out, and that adjusts the air pressure to tune it. You'll notice there's something red at the far end. I'll come to that in just a minute. Next slide. And that is to do with what's called double stacking. That red bit, and you can see it pictured there on its box, it comes in a lovely box, basically is a second etalon, and the two together increases the contrast and also the resolution. So you actually get almost the best possible images you can have. I must say the best picture I've ever seen, or best view of the sun in H-alpha I've ever seen, was actually in the Sahara Desert with a double stacked Coronado telescope like the one you just saw. They are sadly expensive. That one you see on the lower right there costs over £1,000, but the Coronado one happily is a bit less expensive. So the next slide. So we can image the sun. So how can we go about it? Well, the simplest thing is simply to hold up a smartphone to the eyepiece of your telescope. Obviously, it's got to have one of these filters on the front, and which type of filter will depend upon the color you get. That picture, I think, would have come using that darker filter, not the silvery one. Now, for £12, next slide, £12 only, you can actually buy from Amazon an adapter that actually enables you to clamp your smartphone in it. That's the bit that's on the lower right there. Above that is a clamp that goes around the eyepiece. And of course, you can then align the lens on your smartphone camera with your telescope eyepiece. It's called the exit pupil. And I must say, these latest smartphones are fantastic, and I'm not convinced you'll do any better than doing just that for your smartphone plus perhaps £12. Obviously, you can use more expensive cameras for that, but we do have another way of doing it, which I'll come to in a moment. So the next slide. So the way that most of us try and do it is using a thing called a webcam. And it started off actually when Philips had the 2Cam 2 webcam. And what you can do is to take lots of very, very short exposures. Now, the atmosphere above us, as we all know, blurs the images we have of whatever we look at, particularly things like the planets, because they're very small. Sometimes the atmosphere is a little bit clearer, so the image is a little bit sharper than others. So what you do is with one of these webcams, you might take 2,000 images quite quickly. It might take you a minute, maybe a bit more than that. And then you have some software that extracts the very best of them, the sharpest, and adds them all together. And that can do a lot to eliminate the effects of the atmospheric turbulence above our heads. So that's how we do it. The next slide shows you a couple of these webcams, two of the ones I've got. I've actually got a third one now. They cost a couple of £100, but they do enable you to make wonderful images of, say, the sun, also the moon, and the planets, because you can remove the effects to some extent of the atmosphere. So the next slide. And this is a picture I took with one of mine quite recently. You see a little bit of the solar granulation, but the most important thing you see there is a rather lovely faculae. And that actually is basically a line of prominences that if that was on the edge of the solar disk, you'd see coming out from the sun. But they're coming out towards us and they're obscuring some of the light. So that's quite a nice picture. Next slide. This is one where I've overexposed the actual surface, because you can't really see any details there, just to show you the prominences. They tend to be quite faint. So we tend to take two images, one to expose the surface of the sun correctly, and another one to expose the prominences, and then we add the two together, as we shall see. So the next slide. And that's a full disk image. And again, in fact, it's the same one where you saw that rather lovely faculae, but you can also see some little white regions around there, around the sunspot, and quite a number of prominences around the edge. So that's a full disk. And I've actually had to buy a new webcam because my previous ones wouldn't allow me to have a full disk image, which I very much wanted. So that was one of the things I bought during the summer just to keep me going during this terrible lockdown. So the next slide. And this is one I've taken. And again, it shows sunspots. It shows these faculae. There are quite a few on the lower left and some very lovely prominences you see out there on the left-hand side. So that's actually showing quite a nice video. This, I might say, was all during the last solar cycle. The next slide. Okay, if you have a Barlow lens, I'm sure some of you know about those, you use them with the normal telescopes, you can increase the image scale and then you can get some lovely detailed images of sunspots and the regions around them. And that's actually worked out pretty well. You do get some lovely images in H-alpha. They look almost like pictures. Someone drew a painting of them. It looked very much like, in fact, Vincent van Gogh's sunflowers, actually. Those lines coming away from the dark central portion of the sunspot. The next slide. And again, that day when I rushed back from southern England, first of all, having imaged it in white light, I got my H-alpha telescope out, and there, sometime later, I was able to actually image Mercury, shown as a little black dot. So I was really very proud of those. Sadly, the southern part of the UK was totally covered in cloud, so it was only us in the north, which normally doesn't see very much of the sky, that managed to get the transit of Mercury in 2016. Two of the most wonderful days of my life were when I first, in 2004, saw the transit of Venus from Jodrell Bank. We actually imaged it through my own telescope, actually, for Granada, on the top of the Jodrell Bank control room. And then later, 12 years later, I was lucky enough to go to southern New Zealand and saw the whole of the transit of Mercury down there, the second one. Not many people managed to see two. And from the observations there, I was able, with a colleague, to work out how far away the sun was. We weren't very accurate. Anyway, the next slide. And this is where one combines two images. That's quite a nice picture showing some sunspots, those white regions around it. But I also, and you see the granulations on the surface, I also then did a longer exposure, next slide, that shows those rather lovely prominences. And then with a little bit of jiggery-pokery in what's called Photoshop, you can combine the two to get this little picture here. Next slide, sorry.
Ooh, nice.
And there we are. So that's showing the prominences and also the surface rather nicely. So that's the sort of thing we try and do with our H-alpha telescopes. So the next slide. Well, this is just giving you an idea of the rotation of sunspots around the surface of the sun. That was July the 12th, 2016. You see that sunspot not far from the center. And the next image, next slide, that shows it on the 16th, not only a few days later, but there I've imaged it when it's very, very close to the right-hand sort of terminator, or not terminator, the right-hand limb of the sun. So actually they move across the surface quite quickly. And the next slide. Well, this is the great news-ish. Cycle 25 has begun. After this terribly long, dull, nothing to see period, the solar minima that we've had, we began to see some sunspots last autumn. So the first decent group appeared last November, and we'll have the next slide. And that's a picture a colleague of mine took in white light. You can see that little group of sunspots down towards the lower left. And then the next slide shows my image in H-alpha, showing you the same sunspot groups. And again, I think you can see that the center part is called the umbra. Around that's the penumbra. But can you see around the edge of that, it's slightly brighter?
Yes.
And that's what I was saying. The heat that can't get out where the sunspot is tends to work its way around the edge. So that was the first decent sunspot group we saw. We then saw in the next slide this particular little grouping. And this is the best we've actually seen so far this cycle. Two lovely sunspots there. There's a faculae arcing over on the left. I think it's hidden on my view. You might see there's a very nice prominence down to the bottom there. And you can see those rather lovely bright regions around. Now, incidentally, that picture that I took, if you ever look at Sky and Telescope, that's the wonderful American magazine, they've actually showed the same image by two different people in February and March's magazines, and they look almost the same as mine. So perhaps I should set my picture in somewhere, because I'm quite pleased with that one. So that's the best we've got so far. And sadly, since then, we haven't really seen very much. It's got rather quiet again. Next slide. So that's the best we've done. But look, things are happening. And over the next year or so, the number of sunspots will increase. There'll be more and more for us to see. But finally, just a little bit about solar eclipses. Be careful how you observe. I know we all wear these glasses as we watch the first phases of an eclipse. The next slide. This is a point I'd like to make. The moon is in an elliptical orbit. Sometimes it's further away, sometimes it's nearer. And can you see that makes quite a difference to its size? And it's actually when it's at its nearest and quite big, and full moon, we get what are called these supermoons because they look so bright. Now, when the moon is furthest away, it's not big enough to totally cover up the sun. We get what's called an annular eclipse. Next slide. And that's where it can't quite cover up the sun, and we get an eclipse like that. Normally, though, the moon is near enough, so we get an eclipse track where you could see a total solar eclipse. Next slide.
That looks like the results of my eye test.
Yes.
And that's why you need glasses, Miss Duncalf.
Yeah, I must say, the reason I'm not wearing one now mostly is because I had 2 cataracts removed. I'm now no longer myopic, but I need to wear glasses to see things close up. Which is
okay.
I can't grumble. But this is a lovely picture, series of pictures taken in Spain. Can you see the annular eclipse right at the center there?
That's a beautiful picture.
It is super, isn't it? That was in 2005. In fact, a friend of mine was actually in Spain at the time. So the next slide. That was near Valencia. And this is the sort of thing you can image just before you come towards totality. Obviously, you've got to have your special filters on your telescope. Next one. Finally, the sun almost disappeared, and we get a little ray coming through at one point. They call this the diamond ring. It looks rather pretty.
Ooh.
And next, oh, it's gone small again.
Uh-oh. Let's see if we can remember where the button was. Hey.
That's it. Well, you are good. Okay. And the corona, that white light coming away from the sun. The next slide. And finally, during totality, we see the wonderful solar corona. It's white light scattered by electrons in the outer atmosphere of the sun. At solar minima, it actually shows the magnetic field lines beautifully. You see them on the lower left, top right, and we have these wonderful streamers that tend to go out along the equatorial direction. And the next slide. I think this is the last one. Well, there's only one total eclipse that we have a chance of seeing in the next few years. There have been a few recently, actually. One last year in Argentina, one before in Chile. But this one goes right across the United States, as you can see there. So perhaps one should start saving one's pennies. And we hope that by 2024, we'll be able to fly across the world again. So I hope that's been of some interest and nice to be with you. Cheers.
Ian, thank you. You fantastic sun worshipper. Let's clear this off the screen. Wonderful. Thank you so much. We've amassed it. Well done. How was that? 59 slides. Well done.
Well, I hope that wasn't too long. That's slightly worried. It was longer than I expected, but it was not too bad, I hope.
It was fine. Let's see. We've got a couple of comments here. I know we've got Eleni and Jonathan waiting in the green room. Hopefully they don't have any urgent pressing appointments and need to disappear off out of their houses right now, because we are slightly kind of a couple of minutes behind, but that is fine when you're online. It's not like we've got EastEnders coming up after this, is it? So let's have a look. I have got Badar solar film. Will they work on astronomical binoculars, as I don't have a telescope, says Sonia.
Yes, they will. They will. Just make sure, cut out 2 pieces of the film and wrap them around and use, insulation tape to make sure they can't possibly come off. And that will work for you. And that will actually work very well. Well done.
Watching Mercury and Venus transit gave me a sense of looking into the solar system, almost a 3D perspective. Totally.
Oh, nice. Thank you, Jeff.
Yeah. Let's have a look. Brilliant. So very educational. Thank you.
Thank you, Michael.
John Anderson. I think he's from Lee Observatory, isn't he, John? Excellent as ever.
Oh, he must know me. Oh dear, that's bad.
And I know it's great for the ego, this software is. You just get flooded with nice comments, Ian. Okay. And finally, last one from Bob. Excellent presentation, Ian. We really enjoyed that. Thank you so much.
My pleasure. Good to be with you. And I'm sorry I couldn't do the slides myself. I don't think it mattered very much.
It's all right. It kept me focused on the presentation, Ian.
Good. Good. Okay. Have fun. Someday we may meet again at Ligwi. Let's hope so.
Oh, so we are members of Astro, Macclesfield Astronomy, and every couple of months we go to Ligwi, which is a lovely dark sky area on Anglesey. We stay in a bizarre accommodation with dormitories, and it's a Girl Guide school, isn't it?
Yes.
And we go there, and I steal your telescope, which is great.
Very good. I mean, lovely to be with you. Thank you.
Thank you, Ian. It's been a pleasure. See you soon.
Bye.
Bye. Ian Morrison there. Lovely. Thank you very much for all of these lovely comments. I'm trying to get, what was that one? I just scrolled up there. Vicky, you look, where's it gone? Vicky, you look, I just saw something about me then. You look really cold. And I've got this is Celestron torch and hand warmer here. Thankfully, I had this in the car. The heater broke. I'm in a building with glass walls that is completely unused at the minute. And I really just want to put the end of my nose on that. It's freezing. That's really very pleasant. Oh, right. Okay. We're going to go over to our next guest in a moment. Let's just resize some windows, do some IT. Okay. So nextly, Cosmo the Telescope Sloth, who dangles on the end of my telescope. He's not been looking down the telescope this time. I want to see who can be the first popular astronomer to answer in the comments this conundrum. Okay, so Cosmo has been listening to a telescope, kind of. And what he's been listening to is a 3-letter palindrome. That is a word that can be spelt backwards as well as forwards. I think redivider is the longest palindrome in the English language. So he's been listening to a palindrome. What could it be? This sounds like a really lame crossword clue. Okay, now his hearing is going back in time to a strong narrowband radio signal received on August the 15th, 1977 by Ohio State University's Big Ear Radio Telescope in the United States. The signal appeared to come from the direction of the constellation of Sagittarius and bore the expected hallmarks of extraterrestrial origin. What could he have been listening to? It remains, he says, the strongest candidate for an alien radio transmission ever detected. First person to guess what that could have been that Cosmo has been listening to, drop it into the comments. You will win £2 million. First time round was £1 million. This time it's £2 million. SPA, we've got deep coffers. It's fine. Okay, what could it have been? Oh, who got it right first? Somebody's put lol. No, it's not. Paul doesn't count because he's an employee of the SPA. Ian Baker with his new eyes. It's the wow signal. Well done. The wow signal was a little mark on a graph. Astronomer Jerry R. Eman discovered it. He was so impressed by the result on the printout, he circled the reading and wrote the comment wow on its side, leading to the event's widely used name. The entire signal sequence lasted for the full 72-second window during which the Big Ear was able to observe it, but it has not been detected since, despite several subsequent attempts. How exciting is that? And Cosmo listened back in time and heard it. Right, off you go, Cosmo. Throw him in the laundry. Okay, we're now going to go over to Eleni. Here she comes. Our new traffic and travel reporter. Hi.
Good evening, everyone. Good evening, Vicky. I hope everyone is okay and enjoying the show.
Oh, thank you. How are you today?
I'm all right. I had a very interesting experience earlier on. I managed to ask my first ever question in a colloquium where I was the only master's student and everyone else was like up there. And guess what? During the time that he was responding to me, the presenter, Zoom threw me out. And I had to quickly get back online. I was like, oh!
And what was the question?
I don't think they noticed because when I got back in, he hadn't finished yet. So I was like, thank goodness for that. But yeah, it was a little bit of a... I'm glad it wasn't a live event. If it was a live event, well, I don't know. If it's a live event, no one can throw you out. But yeah.
So, Eleni, you are our new roving space reporter, and you're going to give us a bit of space weather as well. So, do you want me to share this screen now and go over to it? Yeah.
Yes. Let me make my screen big. There we go.
And I'll put this full screen. Can you make your presentation full screen?
Yes, of course. Let me know. I just clicked on it. It should do it.
I know. Let me get rid of this banner. Hang on. Banner. I can get rid of that. There we go. Okay, off you go.
Everything looking good? Cool. So today I've got two pieces of news for you guys. One of them comes from the University of Cape Town in South Africa. And it comes with a fancy title, Cosmic Beasts and Where to Find Them. So it's about two giant radio galaxies, and they were observed using MERCAT, which is a radio interferometer, and it's also installed in South Africa. Now, we hear about radio galaxies all the time. Why are these two interesting? So, a little bit of background, radio galaxies are fairly common, but for them to classify as giant, they need to be at least 22 times larger than the size of the Milky Way. So their jets have to be at least that big. Now, these two fellas that you see on the screen are actually 62 times larger than the Milky Way. So they're not just giant, they're gigantic. So what you see in the picture, so you understand what we're looking at, is a background in optical, and overlaid on it are the two galaxies in red. What's even more interesting is that they were both found in a very small patch of sky, about 4 times the size of the moon. And this is at odds with how many giant radio galaxies astronomers have observed, because they have observed very few. So this leads to the assumption that they must be much more common than what observations show, and that we're probably limited by the current technology. So hopefully there will be more to come in the future. So now we're going to go from gigantic galaxies to a much smaller thing. We're going to go into an exoplanet system with certain peculiarities. So this one is a 6 exoplanet system with a rhythmic movement. And what this actually means is that every planet that goes around the star, except for the innermost planet, is actually in resonance with one another. Now, I'll explain that in a second. Just to let you know that the data was gathered by a multitude of observatories, including a very large telescope and Cheops, which is a satellite in orbit dedicated specifically to exoplanets. And the host star is about 200 light years away from us in the constellation of Sculptor. Now, why is that interesting? What does it mean that they are in resonance? It means that their orbits actually follow specific patterns as they go around their host star. And despite the fact that their orbits are very organized in that way, their densities are very weird. So the densities are very disordered. And I'm saying that because observations revealed that there is a dense Earth-like planet very close, literally next to a fluffy, very low density Neptune-like planet. And based on the current planet formation theories that we use, this doesn't really make much sense. There isn't much room in these theories for such an arrangement of planets. You can't have a very dense planet literally next to a very light, fluffy Neptune-like planet. So this system is probably going to make astronomers rethink what they know about planet formation and the current theories. One tiny tidbit that I thought was really interesting about that resonance is that their resonance is very similar to one we see in our own solar system. It's very similar to a resonance between Jupiter and 3 of its moons, I believe Io, Europa, and Ganymede, which is something quite interesting. And finally, I've got some space weather news for you. So a stream of solar wind is coming towards us. And it's particularly interesting from people who live close to the Arctic. So if you live close to the Arctic, you should get your mittens on, get a hot cup of tea or coffee, go to your backyard next Tuesday, and hopefully you can catch some beautiful auroras in the sky, and you can take some nice pictures and post them to us or send them to us so we can have a look as well. That's all from me.
Oh, that was really good. That was your second time. How was that for you?
That was really nice. I really enjoyed that.
Yeah, excellent. A flawless and wonderfully amazing in-depth subject. Okay, well, it's Friday night. Go out on the town and have an amazing night. Go to the party in the discotheque and then get a kebab. Oh, sorry. No, you just got to stay on your own.
I will probably eat and watch Avatar. Very adult things.
Have a great night and see you next
guys. Week. Enjoy the rest of the show. Bye.
Thank you. Bye. Bye. That was great, wasn't it? Thank you, Eleni. Thank you. Okay. Where are we getting up to? Blimey. Have we got any comments? Let's have a look. Brilliant. How good was that? Yeah. She's our new signing. Excellent. Next week, we'll do space traffic and travel as well. Maybe ISS traffic jams and such like. Oh, lovely. Now, next week, we have got David Hardy on. You might not know his name. Well, you might. But if you don't know his name, you will definitely know his artwork, because since the 1950s, David's amazing, almost kind of like photorealistic space artwork has populated books, news articles, magazine articles, practically everything he has painted throughout the years to help illustrate amazing concepts like exoplanets and what have you. So we have got brilliant space artist David Hardy joining us. As you can see there he is. Love the Aurora pic. Yeah, it was a good one, wasn't it, Jeff? Okay, and thank you. That's the highest praise indeed when Paul says, well done, let me tell you. Oh, thank you, everybody, for those kind comments. There's such a nice boost for us. Thank you. Thank you. Thank you. The volunteers here at the SPA. Right, now then, slightly behind time, we are going over to our third-ish and final-ish guest. We are going over to Jonathan McDowell, recently spotted on BBC News talking about the new launches by SpaceX. Jonathan is a great space expert, now living and working in the States, where he works with the Harvard-Smithsonian Center for Astrophysics. And we are talking Chandra. How's this for a build-up, Jonathan? You are coming in 3, 2, 1.
Hello there. Hi, Vicky. Hey. How are you?
Well, I've just got to because we had a little chat yesterday, and I said, "Are you at work in university?" And it turns out that is your house behind you.
Yeah, I have a little bit of a substance abuse problem with books, and so yeah, I live in a little library here. Lots of great space books.
Oh, do you know what? Yesterday when I spoke to you, I really thought that you just sounded American, but now I can definitely hear the English in your accent.
Yeah, you know, the accent kind of comes and goes depending on whether I've been talking to other Brits lately. But, but yeah, so, I am an ex-Brit, an ex-colleague of Ian's at Jodrell.
Oh, yes, okay.
And I just discovered by email that Eleni and I have something in common in that she went to Royal Holloway, London, where my dad used to be on the faculty. So I spent a lot of time there too.
It's weird, isn't it? I mean, I lived in America on and off. In fact, I can hear it coming back now. I lived there on and off for maybe about a year, and I only have to speak to an American person before my R's start changing, and I start. Yeah, it's weird how like it just gets you instantly, isn't it?
Oh, yeah. Well, it's a attempt to connect, right? Your subconscious tries to match the other person in a way.
Oh, brilliant. Okay, so what are we going to talk about tonight then, Jonathan?
Right, we're going to talk about X-ray astronomy and the amazing Chandra X-ray Observatory.
Give us a little Chandra 101, would you please?
I will, if I can successfully share the screen. Let me see if I can... Bear with me just 1 second here.
Okay, I'll dance.
Is that the one? That is the one.
Maybe I won't dance.
Do you see it?
Oh, hang on, let's have a look. Diddly-dee. Yeah, I see stars.
You see stars. So here we are, space, the final frontier. And if you have a boring telescope, like say Hubble, you will see in this particular part of space just stars and more stars, which, you know, don't get me wrong, stars are great. But if you have an X-ray telescope and you look at the exact same spot of space, this is what you see. You see the Tycho supernova remnant about 10 light years across, and visibly over the 20 years we've been looking at it with Chandra, expanding. Every time we come back and take another picture of it, it's getting a little bigger. And so the reason why you can't see it in the normal picture is because this is gas at 1,000,000 degrees. And if you heat something to 1,000,000 degrees, it goes completely transparent in visible light, but it's glowing like crazy in X-rays. And so you get X-ray telescopes to look at all this stuff that you just can't see any other way.
Jonathan, can you just do that amazing trick where you show us with and without X-ray goggles on, please?
Absolutely.
Before and after.
So here is the field before. I didn't manage to quite size them correctly to do it right, but and then we switch on our X-ray goggles. Oh! And here is exactly the same part of space, but with the X-rays added.
That is a beautiful, beautiful image.
Yeah, it's a great image. And what you see there in blue is the shock wave going through the interstellar medium at about, I don't know, many thousand kilometers a second. And then behind the curly red, the kind of cotton woolly red stuff is the debris from the explosion, the freshly baked elements from the supernova explosion, because of course, as you all know, you are made of stardust. every atom in your body was forged inside a star, and these supernova explosions are one way that those newly made elements are scattered through the galaxy to become the next generation of stars and planets.
So then why do we need X-ray astronomy then? Why not let's just stick with Hubble?
Yeah, well, because you would not be able to see that at all, right? And so we can see with X-rays, we can see supernova remnants like this. We can see matter falling into black holes that gets really hot, anything that gets really hot, right? And so Hubble sort of sees the ordinary part of the galaxy, and Spitzer and other infrared telescopes see kind of very cold regions where stars are forming, for example. And then X-rays see the parts of the universe where things have gone very badly wrong, so exploding stars, black holes, very hot gas in clusters of galaxies, so it's really having if you only have the visible, right, it's sort of like you're walking around, you can only see things around you that are colored green, and things that are colored red and blue are invisible to you. Right? And so you've got to have a full array of wavelengths, and therefore the full array of telescopes. So we launched Chandra back in 1999, and if I can let's see, move on to this one. Is that sharing? Yeah, thank you. So Chandra sits about a quarter of the way to the moon. It's at 140,000 kilometers up, because these X-rays come across the universe for maybe 1 billion years, and they get stopped in the last fraction of a second by the Earth's atmosphere. It's very annoying. The X-rays don't reach well, it's actually a good thing that the X-rays in space don't reach the ground for most people, but it's very annoying for X-ray astronomers. And so we sit on Earth. We actually sit at Harvard in near Boston in Massachusetts, at the Science Center, and we have a control center a few miles away that talks to the Jet Propulsion Laboratory in California, that then has 3 sets of radio dishes stuck around the world in California, Spain, and Australia. And as the world turns, at least one of these can see Chandra orbiting the Earth, and so every now and again we get to chat to it and download the latest images that it has taken. And so it's a pretty fun mission. As I said, it's been going now for over 20 years, which is a lot in sort of space satellite years, and we see all kinds of things that you can't see in optical telescopes. So if you look at the center of the galaxy in an optical telescope, you just see nearby dust clouds. The soot of interstellar dust just soaks up all the light. But in X-rays, we can see all the way into the middle and see here is Sagittarius A star, the monster, the black hole in the middle of our galaxy, and various supernova remnants and star formation regions around it. So we can watch Sagittarius star, and even it actually flickers every time it kind of chomps down on something. So we can get a really good understanding of what's going on in the middle of the galaxy, and indeed look at extragalactic objects. And this is one of my favorite images, which is a composite visible light radio astronomy image and X-ray Chandra image of the galaxy Centaurus A, NGC 5128. And so it has this galaxy, but shooting out of the galaxy in 2 directions are these jets that you can see in radio and X-rays, but not in visible light. And you can see them sort of blowing and splashing as they hit the intergalactic medium. And these jets are going at almost the speed of light, and they come from the very central light year of Centaurus A, from the big black hole in there. So we can see we can get a fully rounded picture of what's going on that you just don't get if you only look in visible light. So that's sort of the quick what Chandra is and why we need it.
Absolutely fantastic graphics. So what makes X-rays in space then? Is it a big X-ray machine that can X-ray a black hole with a broken leg?
Right. Well, the thing that people get wrong about X-rays, right, is that if you look at an X-ray of your broken leg, right? The X-rays are not the bit with the leg; they're the white light around it. So the way that you take a medical X-ray is you photobomb the picture of the X-ray lamp, and what you see is the shadow. So we're not, in X-ray astronomy, we're mostly not trying to take pictures of the broken leg. We're trying to take pictures of the X-ray lamp behind it. And those X-rays are made whenever, like I said, whenever matter gets really, really hot, essentially. And so we see when you get extreme conditions, you get X-rays. And so, for example, as matter falls into a black hole, famously, once it goes in the black hole, you can't see it anymore, right? But on the way in, it gets sort of ripped apart by the gravity of the black hole and gets really hot, and that glows, and that's what we call quasars.
Ooh, okay, wow. So if you've got any questions for Jonathan, any very smart questions, feel free to drop them in the comments. Ian Morison, you worked with Ian, who was our speaker earlier, did you, at Jodrell?
Yeah, we were there at the same time. We weren't working on the same stuff exactly, but I remember hanging out with Ian Coffey in back in the Jurassic era, and so yeah, I had good fun as a radio astronomer. But I decided it was time to expand my wave bands, and so I hopped the pond to the US and became part of the X-ray group here at the Center for Astrophysics.
It sounds a bit more kick-ass, to be honest, X-ray astronomy.
Well, the thing about it is, it's space travel, right? So you have to, radio dishes are very pretty. I loved having the Lovell telescope, the Mark I, outside my office window. That was an inspiring sight every morning. But to be able to be part of a NASA space mission and be working with folks who are communicating with the spacecraft, so way out in space, and being able to sort of command it to go and look at a different part of the sky. That's pretty fun. So it's been really exciting being it's not quite being an astronaut, but it's the closest I'm going to get.
Okay, now somebody here says they like your T-shirt. Now I don't know what's on it today. What have you got on it?
Oh yeah, this is.
Whoa!
I think this might be part of the antennae. I'm not sure. I don't remember exactly what this is, but this was a great company that used to make these Astro image T-shirts, and sadly they went out of business. So hopefully they'll come back sometime. But yeah, no, I like the. This isn't the one I meant to wear when I chatted with you yesterday, but it's still, I like it. It's a pretty T-shirt.
It's pretty cosmic, and because I'm in a room with a broken heater, there's no chance of my wearing a cosmic T-shirt tonight.
Fair enough. No.
Now,
yeah.
I was just going to say, drama with the shuttle and Chandra. Tell us about that.
Oh yeah. So we launched. So Chandra is a 5-ton spaceship, right? That was boosted up into space on the space shuttle. So we were, this was 1999, and I was down at Cape Canaveral at Kennedy Space Center, watching my entire career go up on a pillar of flame, right? So about 5 seconds after it went off the launch pad, there was an electrical short in the wiring in Columbia that caused one of the main engine controllers to go out. So the space shuttle had these 3 massive rocket engines on the back end of the orbiter, and each engine, or they have 3 engine controller computer kind of things that each control 2 of the engines, and so each engine has 2 controllers, so there's a backup. And one of these went out, and so basically a few seconds after launch, as the shuttle cleared the pad, the commander's control panel all lighted up red. All kinds of alarms went off, and like you've lost 50% of the control of 2 of your engines. And if you have another electrical short, which could easily have happened because there was a lot of crappy wiring, they found out afterwards, you could lose both engines and have to ditch in the ocean. So that was a bit nervous making. And there, but they sort of pressed on calmly. And but you can find on the internet all the sort of back channel talk from between the flight controllers that we didn't hear at the time. But unknown to them at the time, there was also a hole in one of the engines, a second problem, that it was spewing out rocket fuel and a little flame to the side as well as out the bottom. And so they actually ran out of fuel before they got to orbit, but fortunately only like 5 seconds before they got to orbit. And so they ended up in an orbit that was a little low. But they had a hard out of gas shutdown on the engines. And so, this is the sort of nightmare you have in a space launch, that when you have two separate problems, that's when things can go really bad, because you protect against, any one. But we were just very lucky that the two problems didn't kind of amplify each other, and so it was pretty hair-raising. We ended up in slightly the wrong orbit for the deployment, but it was okay because we had a booster to get us up higher anyway. And the commander, this was the first shuttle mission commanded by a woman, Eileen Collins, and she was sort of so cool and collected during this emergency that I understand that the rest of the astronaut corps nicknamed her Janeway afterwards, for those of you who are fans of Star Trek Voyager. But she and her crew did a fantastic job in getting us into space, and we were, like all good Star Treks, we were on a 5-year mission. And like all good Star Treks, we've had spin-off continuations, and we're still going more than 20 years after that hair-raising day in Cape Canaveral.
Wow, Jonathan, thank you so much for explaining about Chandra. Now, we had a choice. You told me that you've got 2 different lives. There is X-ray, Jonathan, and space launch, Jonathan. Give us a little bit of an insight, because I think we're going to have you on in a couple of weeks to go about your daytime and nighttime versions. What are they, Jonathan? Right,
yeah. So in my day job, I'm hunting for black holes with Chandra and helping the mission do its job. But then in my off hours, I have a website, Jonathan Space Report, that gives an update on all the different satellite and space launches, and it has sort of a database of all the rockets that have been launched and all the satellites that have gone up. And so I've been sort of like the chronicler of the space age. And I started off, as a kid. I was really frustrated in England that the media didn't cover satellite and space launches very well. And so I was forced to do my own research, and it just ballooned and took over. And so now I started making this list of rockets, and now 40 years later I have the best list, and people come to my list. So I try and keep track of everything that's going on up there, and that's been really fun. And I've sort of been dragged a little bit from just being a number cruncher into a little bit of the space policy stuff as well. So I've been involved in some of the discussions around the big new satellite constellations and how they might affect astronomy.
Oh, wow, Jonathan. Well, we'll schedule you in for a couple of weeks from now. And thank you so much for explaining Chandra. I've got a Chandra fridge magnet. I think that's quite an obscure fridge magnet, isn't it?
Yeah, I don't know that. I don't think I've got a Chandra fridge magnet, so I'm a bit jealous.
Yeah, I can only see it when I wear my X-ray specs, though.
Okay, fair enough.
Did you ever have those X-ray specs? Didn't they have feathers inside them?
I never. I don't know. I saw ads for them, but I never actually had them myself.
They were like they were a gimmick, weren't they, in the comics? And I'm sure that they were like just bits of cardboard with possibly maybe just red feathers inside them. Definitely no X-ray technology.
Yeah, no. I think maybe they were like polarized or something, but at best, yeah. So yeah, no, really. And also, if you had X-ray vision, right? I mean, this is the whole thing about Superman and so on. X-rays don't go very far in normal air.
Okay.
They certainly don't go through your the wall of your building. So really? Actually, if you had X-ray vision, you'd be almost blind. You wouldn't really see very much.
Just you could see a fracture at 6 inches.
Yeah. Also, unless your eyeball was like really, really smooth, right? In order to focus light, you have to have your telescope right, smooth on the wavelength scale of the light you're looking at. And X-rays have 1,000 times smaller wavelength than visible light. And so you have to, when we made Chandra's mirrors, we had to make them ever so smooth, like, oh, there's an atom sticking up, we better sand it down.
An atom?
Well, about that size, because the wavelength of X-ray light is about the size of an atom. And so you know, that's another reason why the spacecraft is a bit expensive. Yeah, and so if you just have like normal eyeball but looking at X-rays, then you're going to have very blurry vision.
They could have saved themselves millions if they'd have put some feathers in Chandra instead of. Apparently the feathers caused a diffraction effect. Don't know why they didn't think of that beforehand, before launching it.
Yeah. Well, we made some mistakes, but that wasn't one of them. Yeah.
Oh, Jonathan, it's been an absolute pleasure. Thank you so much, and see you again in a couple of weeks. Okay.
All right. Bye-bye now.
Bye. Bye-bye. Wow, that was fantastic. Jonathan there on using red feathers to see into the heart of black holes. Wasn't that amazing image, the before and after? A blank patch of space versus a Chandra vision patch of space. Right. Thank you, Jonathan. I know that was so lovely, wasn't it? My computer's starting to slow down and get very hot. That's the only thing that's hot here in a 1 mile radius, I think. So I think I'd better go. Now, thank you ever so much, everybody, for coming on this evening. Just a little plug for me. I am Vicky Duncalf, aka Vicky Video. I can make videos like this for your organization or your business. So get in touch if you want anything like this doing. I am available. So there we go. Okay. Thank you to everybody who's participated. Ian Morison, Eleni, and Jonathan. Let's just have... Now, what tends to happen in the last... my nose is so cold. I feel like a dolphin or something with a wet, cold nose. What tends to happen is after I switch the off button, a load of comments flood up because I think there's a 10-second delay. So if you want to write anything now, get it in the comments for the very last thing. And I'm going to start packing up from the laundry. The stables that are a laundry. There is no heating on. I've got to buy a new heater now. That's a bit of a bummer, isn't it? Okay. So please join the SPA. It is a snip at £23 a year. You get the magazine. I've not got a copy of it here. SPA merch is available. This is an Anna Lemon necklace. This is just a small sample of SPA merch. We've got T-shirts. We have got mugs, which I plug on a regular basis. What else have we got in the shop? Models, lovely flickery poster things. I don't think I've got any down here. I'll bring some next week. And who have we got next week? We have got, just let me check my diary. Just go on Facebook now. We have got next week. Oh, it's good next week. We have got David A. Hardy, space artist, and Stu Clark is joining us again. You will remember how much fun Stu is. Last time he was on, I made him play Opportunity Knocks, and he had to do an interpretive dance of Curiosity the rover, which I don't think he has ever forgiven me for. So please join us next week. Thank you for all the lovely comments. Oh, the SPA has a regular meeting tomorrow afternoon. Maybe I should go to that. Oh, thank you, everybody. Thank you for the lovely comments. Once again, the great Friday night show. Yeah. Oh, thank you. Won't get me head out the door. Oh, thanks, Kath. And you're a lovely lady as well. Oh, thank you. Is there an SPA hot water bowl for Vicky? No, but I have got a Celestron hand warmer, which is the next one up. Very, very powerful bright torch and power bank included as well. Okay, everybody. Good night from... Where's the sloth? Where's the sloth? He's in a pile of laundry. Let me get the sloth. Say goodnight to Cosmo. I just threw him earlier. There we go. It's been a wonderful show this evening. Thank you, everybody. I want one of those mugs. Sonia, I've got news for you. This is like the basic mug. There are much better mugs. I make my drinks the Milky Way and all these others that I can't remember off the top of my head. There are loads of different ones, and they're lovely kind of high gloss and blue effect. Perfect for drinking water from. Good night, all. Better switch off. And good night, David Hardy. Looks like he's watching on Twitter there, according to that little icon. Like having people on Twitter watch us. Share the video. Oh, thank you, Pedro. Don't recognize your name. So thank you so much. Maybe you're a new viewer. Going to switch the off button now. Bye. Good night, popular astronomers. Clear spies. Clear spies. Clear spies. Make sure your spies are always clear. Otherwise, they won't be able to spy on you with X-rays. Catch you later. Share the video. Share the video. Join the SPA.